Alright, excuse my voice, but we're going to go through this review sheet. You should know how to do everything on this sheet. I'm going to walk you through it. What you also need is your reference tables, and for the most part we're going to be looking at the periodic table. Okay, so if you don't have your reference tables, you're going to have to use the online version, which is fine. It's the same table, but have it out. So for A, follow the directions and color the correct locations on each periodic table. Number 1, color the transition metals. Well, the transition metals are groups 3 through 12. So right here, okay, I'm going to color this. Those are the transition metals. Color the alkaline earth metals. Well, that is group 2 because it's the metal one that has 2 words in it. So group 2. Color the alkali metals. Well, that is group 1, but I do not, this is hydrogen, do not color hydrogen, so I'm going to outline it so you could see it's not colored. If you color this box, it's wrong. So alkali metals here, group 1, 1 word before the metals. Color the metalloids. Well, on your periodic table you have this staircase, okay? And the metalloids touch the staircase. The first one right here. The next one would be right here that touches a vertical or a horizontal, not the corners. It touches the horizontal line or the vertical line, but this is aluminum, and that's not a metalloid, that's a metal. So the next one is here. Then we have these two, these two, these two. Okay, those are the metalloids. All right, let's see what we got next. Lanthanides and actinides. So if you look at this periodic table, you see how it says La? That would be right here, and AC would be right here. So this first row, lanthanides, I'm going to color it. It comes after lanthanum. Okay, so there's the lanthanides. Okay, and then let me use a different color for this one, actinides. Okay, lanthanides and actinides. Color elements that are liquids at STP. Well, there's only 2, bromine and mercury. Mercury is right here, and bromine is right here. That's it. Those are the only 2, so those boxes. Alright, color the halogens. Halogens match up amazingly with alkali metals. They're group 17 all the way over here. This would be noble gases. Color the elements that are gases. So we have hydrogen, all of the noble gases. Okay. And then we have nitrogen, oxygen, fluorine, and chlorine underneath. Okay, so that's it. Those are the elements that are gases. Alright, let's go on to part B. Answer the following questions. How did Mendeleev arrange his periodic table? By atomic mass. Why did Mendeleev leave blanks in his periodic table? For undiscovered elements. And remember, he predicted the properties of those undiscovered elements with surprising accuracy. How is the modern periodic table arranged? By atomic number. Alright, let's continue with B. Alright. What do elements in the same group have in common? So let's just glance down a group. What do elements in the same group have in common? If you look at their last number and their electron configuration, they have the same number of valence electrons. What do elements in the same period have in common? So that's going across like this. And if you notice, going across like this in a period, they have the same number of occupied energy levels. Same number of occupied energy levels. Chemical properties are determined by the number of valence electrons. When an atom is stable, it has 8 valence electrons. Remember, that is called an octet. With one exception, helium. And it's not that helium has 2 valence electrons. It has 2 total electrons. You can see it right here. It does have 2 valence, but the important part is has 2 total. This element is in a class by itself. Hydrogen, and you could see it's up separated here. So helium, the exception to the octet, is stuck up a little bit, and hydrogen in a class by itself. Okay. Write the correct group number for each of the following questions. Alkali metals, right here, group 1. Halogens, right here, group 17. Noble gases, 18. Most reactive metals, that's this one right here. They only have to lose 1 valence electron. Least reactive elements, well, that's over here, the noble gases. Atoms with 1 valence electron, well, we're still group 1. Elements in each state of matter, that's the halogens. Most reactive nonmetals, also the halogens. And these two are gases, liquid, solid. Atoms with 6 valence electrons. Group 16. And stable elements, 18. All right, that was C. Now let's go on to D. What subatomic particles are lost or gained to make stable octets? Valence electrons. How will an atom of beryllium make a stable octet? Well, beryllium is Be. I'm going to write its electron configuration 2-2. So it has 2 valence electrons. What will it do? Well, to make an octet, it can either gain 6 or lose 2. So lose 2 is an easier option. How will an atom of oxygen make a stable octet? So oxygen, its electron configuration 2-6. It has 6 valence electrons. So it will gain 2 electrons to make 8. When it gains 2, its oxidation state or charge will be -2. Because remember, electrons are negative. So if you gain negatives, you're more negative. How will an atom of bromine make a stable octet? So that's bromine 2, 8, 18, 7. So it has 7 valence electrons. It will gain 1 electron, and then its oxidation state or charge will be -1. And remember, I told you for now we're only looking at the first one for anything that's negative. How will an atom of cesium, right here, it is 2-8-18-8-1. So it has 1 valence electron. It will lose 1 electron, and it will end up with a +1. Because remember, electrons are negative, so if you lose a negative, you end up being positive. All right, identify each as a metal, nonmetal, or metalloid. So I'm going to use metal, M, nonmetal, NM, and metalloid, ML. So I'm just going to use to make it a little easier. All right, so here's our periodic table. All right. Carbon, nonmetal. Silicon, metalloid. Aluminum, metal. Sodium, metal. Chlorine, non-metal. Copper, metal. Boron, metalloid. Sulfur, non-metal. And potassium, metal. Okay, identify, for our next section here, identify each element as solid, liquid, or gas. All right? So, what I explained to you in class is melting goes between a solid and liquid. Boiling goes between liquid and gas. So, if the temperature is below the melting point, it will be a solid. If it is in between the melting point and boiling point, it will be a liquid. And if the temperature is above the boiling point, it will be a gas. So calcium at 900 Kelvin. So we have to find calcium. Here we go. 900. So imagine this like a number line. Where does 900 go? Well, over here, right? So that means it will be a solid. Chlorine at STP. So remember STP, standard temperature pressure. This is STP. So it is 273 Kelvin. So it was chlorine at, not bromine, chlorine at 273 Kelvin. Well, 273, if this is a number line, it's over here. So it is a gas. Lithium at 600 Kelvin. 600 Kelvin is in between those two numbers, right? So it is a liquid. Iron at 1850. So we have to find iron. 1850. Oops. Iron. 1850 is between those two numbers. Liquid. Sulfur at 900 Kelvin. Sulfur 900 is above that number, is a gas. Neon at 26 Kelvin. Ooh, 26 is right between those. Liquid. Hydrogen at 10 K. Hydrogen, 10 is lower than this one, is a solid. Hydrogen at STP. So hydrogen at 273 Kelvin. That's way over here. Gas. Bromine at room temperature. So room temperature, remember, about 20 degrees Celsius. You add 273 to turn it into Kelvin, 293 Kelvin. So bromine at room temperature, 293 Kelvin. Look at that, it's in the middle. Liquid. And iodine at room temperature. Iodine is on the other part. So see, we are up here. Iodine's on this part. Iodine at room temperature, 293. Here is its two numbers. 293 is over here. So that makes it a solid. And then the last part, what are some properties of metals, nonmetals, and metalloids? Well, metals have luster. They are good conductors. They are malleable, which means they can be hammered into sheets. They are ductile. They can be stretched into wires. Nonmetals are dull, brittle, and poor conductors. And metalloids have properties of metals and nonmetals. They are semiconductors. That's an important characteristic. They are dull. No, not dull. They are brittle and have luster. So they're semiconductors. That's the important part. This is like metals. This is like nonmetals. But the important part is they're semiconductors. All right. So there you have it. That is your entire review sheet. You should be able to do this on your own, but if not, hopefully you came to this video for some assistance.